Good morning, everyone. I'm Alex Meyer, and this is Brandon Hamric. Today, we're going to be talking about deploying Python machine learning using Apache Spark. Just a little bit of introduction about Eventbrite. So we're a global ticketing and event platform. I'm sure most of you have probably heard of us. We have both mobile apps, the web app, multiple organizer apps, and the different things that we provide varies from ticketing to reporting, just a very wide variety. And I think the most important thing there is that we have a lot of different sources of data and data from all around the world. So there's obviously a lot of different issues we have to deal with, and also the scale of that data. So there's some stats down there. In 2017, we had over 203 million tickets processed, and that was in over 170 plus countries. And we supported over 700,000 creators. Some of the examples of data science and machine learning projects that some of our data scientists work on include fraud detection. So just making sure that people are who they say they are and that they're not trying to buy all the tickets, because that's a big thing, bot scalping. Event recommendations, so making our platform more of a destination for finding events rather than just going there to buy a single ticket and then leaving. Topic classification, and then bot detection. So making sure, again, like I said, that people that we don't want scraping the site aren't. A little bit about us. We're both from Eventbrite. The important thing is we're data engineers. So we are not data scientists. And what we mainly work on is shipping models for the data scientists that do all those different things I was talking about before. We both started out working on event recommendations, and then we saw a need within the company to build out a new data infrastructure. And so we built that out to support all the different needs of Eventbrite. So like it says down there, we create, maintain, and support the data infrastructure, tasks, and pipelines. And that's for all the different business needs. Like I said, this is Brandon. He's the principal data engineer and architect at Eventbrite. He's been working in data engineering for about 10 years now, and Spark specifically since 2014. And then I'm a senior data engineer, and I've been working in Spark and data engineering since 2014. Cool. Now Brandon's going to take over.
All right. Thanks, Alex.
Yep.
So I'm going to be talking about structuring predictors, because for us, for data engineering to get a data scientist model into production, it needs to be structured in a consistent way so that when we see it, it's not something new that we have to go and build an ad hoc pipeline for every time. So this entire talk is really focused on being able to structure predictors in a way that we can ship them in the various modes of shipping the model within Spark. To talk a little bit about this, I'll show you our original workflow for getting data science models out, and it was terrible. I'm sure some people can relate to this. So the traditional model is the data scientist kind of does their work. They do data prep and ingestion, exploration and analysis, and then model development. And that's a cycle, and they maybe are working with a notebook, figuring out exactly what their parameters are. Once they have it ready, a lot of times at Eventbrite, most of our data scientists use Jupyter notebooks or RStudio, things like that. If we want to get those into production, we pretty much always go from vertically scaling to horizontally scaling, which is just a pain. So that's what this is really about. Right now, this predictor packaging is always a multi-team exercise, or right now. In the past, this was a multi-team exercise where a data scientist would say, hey, here's our notebook, and in the worst case, ship this notebook that I wrote stream of consciousness, and you figure out how to extract the important features of it, right? In the best case, we have somebody who's kind of a hybrid data engineer who can go in and already break it out for us so we can kind of see which parts are for training, which parts are for prediction pretty easily. And then the rest of that, once we have the predictor written in a way that we can actually schedule it, then data engineering will go in and schedule it. Product engineers will use it. Data scientists will see how the model worked in production using online feedback, and the cycle continues. Issues with this are that there's really high coupling between data engineers and data scientists. I don't know about you guys, but if you've ever heard a data scientist say, I'd love to get this model out, but I'm blocked on data engineering, that's something that data engineers want to avoid. We want to be able to enable our data scientists to be able to move and just get us out of the picture as quickly as possible. It's really a serial workflow, so product engineers At Eventbrite, traditionally would say, I need this recommender, therefore I will wait until this entire workflow of multi-teams get through this model, get it into production so I can ship recommendations to some specific page. And that's really bad. Our improved workflow, you notice there's a bunch of green here, so data scientist kind of owns their workflow. The idea is that, the idea is that the predictor packaging is now owned by the data scientist. How we do that is kind of the crux of this talk. How do we say to a data scientist, data engineering is not in this talk, in this workflow anymore. How do we get it so that you always structure your code in a consistent way so that when we go to schedule it, we actually just use configuration to schedule your predictions. And we can do that in batch and streaming context. So good thing about this is it's kind of the opposite. There's low coupling between engineers and data scientists because there's no coupling. We just release it now instead of going through an ad hoc pipeline every single time. The workflows are independent between the product engineer and the data scientist. So the product engineer, the benefit here is that the data scientist can ship more models using this because they're not waiting on projects to get on our cycles, on our sprints. So they can be iterating on more models, which means that the product engineer can start picking between models, and they're not waiting on some specific recommender engine. There are multiple ones flowing out of data science because they're faster. And then data scientists own their models end to end, and we're not the bottleneck anymore. That's what I'm going to cover. Okay, so to do that, we broke our predictors really into 4 buckets. So those 4 buckets are what we work on training our data scientists to start writing their code into. And those 4 buckets are data prep and cleanup. So the first thing they do is how do I get my code, or how do I get my data that I'm going to push into my vectorization. Feature extraction, so now that I have, and you guys are obviously familiar with this stuff, but feature extraction is an explicit function that takes my cleaned up code and turns it into vectors or whatever their model uses. Model management is kind of the core of being able to iterate on these models, on data science. Being able to pick between versions of a trained model and being able to understand, it's really the problem that MLflow seems to handle pretty well. When I heard about MLflow, I got sad because we worked on implementing a lot of this. And then prediction, obviously, is how do you structure your predictors in a way that they all look the same so that you can just use configuration to pick between them. I'm going to skip the animations. Okay, so for data prep and cleanup, the queries that you use to create your training set can be different than the query that you use for daily prediction, right? Because we only want to run prediction on event descriptions that have changed. So if we're writing a classifier, we only want to classify events that have had their description changed. That's kind of a pain because now you have to rewrite the query between your training and your prediction context. I'm going to skip some of these because I'm killing myself on time. Feature extraction, you actually have a very similar problem. And a really big problem we have with feature extraction is it's mostly written for vertical scaling for those types of like pandas, scikit-learn, that type of data science model. So a lot of our feature extraction is done with pandas, and translating that over to Spark can be a pain. Spark data frames make it a lot easier. But that is an issue we run into. For model management, again, this is a really important part for being able to iterate between versions of your model. It's a hard problem. You need to be able to have some kind of library around it. Again, MLflow does a good job of it. Data engineering at Eventbrite have kind of their own version of being able to do that. Alex is going to kind of show an example. Your models can use a ton of memory, so being able to optimize how you distribute this model on Spark is pretty important, right? You don't want to load it from, let's say, S3 onto every single partition. Instead, you want to probably broadcast your model, and that stuff needs to kind of be baked in so the data scientist doesn't think about that. And then with prediction, bulk and single item prediction is important. So a lot of like linear algebra type predictions are much better to run in a bulk context. You send 10,000 of these to your bulk transform or predictor instead of sending one at a time. So being able to pick between those and handle both cases seamlessly is really important. Do I want to do this one? Yeah, I mean, I've talked about a lot of these issues. This is specific to deployment. So generally, dev is the first thought when data scientists are working on what they're doing. And they want to be able to go through as many dev cycles as possible. And then once it's ready to productionize, because they're focused on dev and they don't want to go through all of the robustness of preparing something for production, what you end up with is having to go through some kind of process to turn it in from this prototype into something productionizable. It's not naturally in that state. Most models, as I said, are written for vertical scaling, and then deployment is generally ad hoc by default without some kind of common structure. And I've talked both of those. Okay, so this is kind of how, when we were planning this project, we kind of broke down the components of the three different contexts. So the three contexts are working in a notebook, and you're working in Jupyter or whatever your notebook is. And generally there, like if you're doing your data prep, it's just querying. I've seen it a lot of times, it's just querying and writing it to a local CSV that they can just load up however they want. It's a much smaller set of data. Feature extraction is almost always pandas data frames for our data scientists. And then loading the model, they'll store it and load it in a pickle locally. This isn't versioned. There's no clean management of being able to switch between them. And then the prediction is mixed into the scoring logic, so it's actually not broken out cleanly into something that we can take and then ship in an automated way. For offline prediction, which I would just basically say RDD map partitions functions, being able to run this in batch, it's a little different, right? So we have to take that query to local CSV and convert it into something that is going to run incrementally. So give me everything that has changed since yesterday. We also need to convert whatever the pandas data frame is, or maybe it's a Presto query because we also use that at Eventbrite. We need to convert that into a Spark data frame or a set of RDD operations to extract the features to be able to predict on. Loading the model, we load it from some distributed file system onto each executor. And again, it's important that you only do that per executor instead of every single partition. And then last, being able to predict either on a map partitions function or a UDF if the features are given in a data frame. Streaming is pretty similar. Convert to a read stream instead of an incremental query. Pretty clear. We actually use our MySQL binary logs. We replicate them to Kafka, and then from Kafka, we actually run our prediction on row-based replicas. So every single time a new row comes with a new event description, we might run a predictor on that to come up with a category. Same thing for feature extraction. We convert to data frame operations. Loading the model works the same. It comes from a distributed system, a versioned distributed system. And then predict is a UDF on feature rows instead of a mapper. I think in Spark 2.4, there's like a map. It's like for each batch or something like that. So technically, in for each batch, you could take every window that you're running prediction on, collect all of it, run prediction, store the results to like Redis or something like that. So we're looking at that for when Spark 2.4 comes out. Okay, so this is like a horrible thing to do in a presentation, but we're going to show you some code. But we tried to break it down in a way that's consumable. So sorry if it's not. All right, so a couple of concepts here. So don't try to read this. It'd be horrible and distracting. What I'm going to do is go through each section. So the important part is that our predictor class, and again, this isn't actually what we use at Eventbrite. This is a really simplified version that is possible to present. So you might see some stuff that doesn't work because this is all like smoke and mirrors. So the predictor class is the class that all of our data scientists will take their models and inherit this predictor class. So we can kind of structure it all in a very similar way. Important aspects is that it manages the model. So you should be able to save the model, which takes in the actual Python object, take a model key, which is just kind of a name for this model, and then any metadata. So Alex is going to talk about the metadata, but this is like, if you look at MLflow, you can store your parameters that you trained your model on, that's what we use metadata for. So we just send that metadata in, and when we go grab or list versions of our trained models, we can see which parameters they were trained on. Loading the model, this part's obviously important because if you want to run predictions, you need to be able to go load a specific version. By default, it's latest, and then it'll just get the latest one from S3. And then list versions is just kind of for development purposes. So being able to go through and figure out exactly which version to grab and kind of understand which parameters were used. Being able to load your data. So we broke this into the two concepts, loading an input stream and loading an input data frame. So all of these predictors, the data scientist should be able to write some kind of input stream off of Kafka or some kind of Spark SQL query or data frame operation that was translated from their pandas. So we give them this to implement, which makes it much, much easier for us to work with. A lot of times when we'll get this, it's not written in a way that it'll pull just the last day's content. So we'll get something that says, pull everything, all descriptions from all of our events since 2012. Well, we'll just translate that into some daily query based off of change. So that is kind of something that we might see in a code review. Next is how do we do feature extraction? And there's really two ways. So again, we prefer bulk. We prefer to do feature extraction on bulk because a lot of these operations are done on in a way that it's more optimal to do it in bulk. And there's a whole blog, I think, on Databricks that shows like bulk versus single item and why bulk is so much faster. And it's for like caching and a lot of the models are much faster to do linear algebra operations on. But it works for both. So the default for bulk is just to run extract features over and over, right? So you can kind of override either one. And then predict works the exact same way. We prefer bulk. If you want to use bulk in your subclass, you override it. If you want to do single item, then you just write the single item one, and then the bulk will call it. The next concept is that there's something I needed to talk about here. What was it?
The automation of those four.
Automation, right. Okay, so yeah, that's like the core of the talk. So once we have all of this, now if you kind of think through it, we can actually, the data engineers can write something that automatically goes through every single model and will run them using just configuration. So if, for example, if somebody writes a text classifier that looks at our event descriptions, comes up with what category it should fall into. To ship it, we would go and call load input data frame. We'd go through that data frame, call extract features bulk on it. Once we have all of the features, we'd pass it into predict bulk, save that result into our cache, right? So all of this becomes automated. There are absolutely edge cases that it doesn't perfectly work for, but this basically lets us say to the data scientist, hey, go fill out these 4 functions. Here's a little bit of training. If you don't know Spark, here's how you can turn your pandas into Spark data frames, or you can write Spark SQL if you want to do huge queries. And then we should be able to, if everything works nicely, we should be able to just pop a version into prod, and then it'll start running in bulk or on streams. And I think that's it for me. Yep.
So that may seem abstract at the moment. I'm going to go into a live demo. That should be fun. And a little bit, so I had about a week and a half to get to be a data scientist for this demo, so this should be fun. I'm going to demo LDA using this predictor class that we're talking about. So you can see a little bit of what Brandon was talking about and the benefits of what it enables data scientists to do to make it really straightforward. And here's the 4 things I need to do, and then past that, I turn it over. And it's all automated. So LDA is, we don't actually use this, but it's something that can be used for generating topics based on some descriptions, right? So if our document corpus is a bunch of descriptions, we can pull out topics per event ID and then use those later for things like search, browse, personalization based on different things that you may like. Cool. So, live demo time.
That's small.
Yeah, that is small. That's too big.
Yeah, just zoom in, go left. That'll work. Yay, live demos.
Can you guys see that? Good. Okay, just to give you guys an idea of what our source data is, here's a little sample. As you can see, our training data is a lot of HTML text-based event descriptions. So this is what you're actually going to see on the website, and we have to pull out stuff that's useless in this, so all the different HTML tags, stuff like that. So as I'm doing my stream of consciousness of wanting to go train based on that data, I'm just going to go through this process. This clean HTML text is just it's a stubbed out function. It's not really too important what it does. But it's taking those source HTML descriptions, pulling out what's important, and making it so I can then pass that into my, my model later on, and my count vectorizer. So the important thing here is I have some source training documents, so all those descriptions, however many I want to use for my training. And then I go ahead and dump them into a count vectorizer. And obviously these are just stubbed out variables and parameters. And then I'm going to go ahead and fit them to the documents. Not too important, but then I just add those into the LDA model to train this model for what we want to do. And again, this whole chunk is whatever you guys want to do for training. It's not too important. The important part is how we go ahead and use it. So I'll skip that since that's not important. So the class Brandon was talking about earlier, save model. So I've just spent all this time, I cleaned up my data, I found out how to get it into the different models and transformers that I care about. Now what do I do with it? This is the save model function Brandon was talking about earlier. Under the hood, it does a lot of stuff with versioning, making it so that if you want to go back and look at all the different times you've trained this and compare them, it saves any data that's unique to my training in this one instance. So I go ahead and build a model with my transformer and my LDA model, and then I just call the save model function. So it takes my model that I built here.
Can I add to that real quick?
What?
It's important to note that the model is a dictionary, and we just did that so we can let them pass in multiple things, right? We have the TF vectorizer, we also have the LDA model. We just let them pass both of them in. If they have a huge pipeline and we have to run each of those things for part of predict, then just put them in a dictionary and it works just fine.
Yeah. And then the important part that Brandon was mentioning earlier is this metadata. So this enables us to go through when I want to look at the different versions that I built before and I want to see, hey, what are the parameters that I set for each of these different trainings and how can I use those to compare across the models to see which is better. So this is our example predictor class. This is based on using the predictor Brandon was talking about. But the important part here is I just implemented the functions I care about. I don't have to implement how I'm dealing with my modeling. I don't have to, the versioning. I don't have to worry about storing it. It's all here. It's all hidden. As a data scientist, I can go in and say, hey, I need a data stream coming from our event changes, which is just a Kafka topic. So they just say, hey, I want my Kafka stream. I want to use the ID and description on that, and that's my input stream. And that's part of what's going to be dumped into using the feature extract and predict function that Brandon was talking about.
And we require an ID field on every one of these. And the ID field will let us associate it with something later, so in the product they can go look up what are the
the data is useless if not. So, and then this is load input data frame, so it's the same concept except for I just want to batch this, so I only care about the events that happened since last known change is when I last ran this. So if we run this every day or every hour, it's going to go and say, hey, go get any IDs and descriptions for the events that changed since I last ran this, because we want to go and run prediction on it. Then, as you can see, I only implemented the bulk functions because those are the ones that it's optimized to use the different transformers and models I'm using. And I'm just going through the documents that are in the rows, using that function I was talking about earlier to clean them, just to get them in a state that I can then use in the count vectorizer. And then all I have to do is go pull from my saved model, like Brandon mentioned, it's a dictionary, and transform it. And then predict is the same idea. So now that I have feature vectors that I just wrote here, what do I do with those so I can actually predict on a bulk chunk? Or I can do a single prediction that will then just go and iterate through and call it on a single feature vector. So for mine, I can just go call the LDA model and transform all these feature vectors I just received.
Our real ones are more complicated.
Yeah, this is just for demo purposes, make it easy and consumable. So now I'm going to go and actually use this. So either I'm a data scientist that wants to see what I've done previously, or I'm someone in product that wants to look at different versions that this data scientist built for me for different types of topics, prediction. So I can go ahead here. I want to see the versions that exist for Alex topic predictor. And like we were saying earlier, it's all this data. So it's all the different parameters that were used to set up the model, the size of it that's actually stored, all these different parameters that are unique to this one training model. And then I can use that to see, hey, I changed max DF in this model to 0.99. How did that affect my output predictions? And as you can see, there's different version numbers. So we, in our underlying load and save, have a version ID and a version number that goes and pulls based on your topic class and has a unique ID. So let me scroll down. Yeah, so now that I've done those 4 things and I've looked at my versions, I can just run a batch prediction. So using some source data that I told this class up here, hey, I want to load this data for my predictions, and then I want to do this extract features on it and this predict. I go and run this one function that says, hey, go get my latest version for this class, run it. That's all I have to do. It's pretty straightforward. And also, like Brandon was saying, it enables automation. So the data scientist can take a step back and not really have to worry about, okay, how do I actually make this run distributed against Spark, and that sort of thing. So this is going to take a little bit.
Live demo.
Yeah, live demo. May crash. That's fun. So I've already done this before, so let me just open up sample output. So as you can see, I have my IDs, and then I have the result of predicting on my source data. Cool. So I'm going to turn it back over to Brandon to finish this out.
OK. I was going to use a takeaway slide, but I don't like it. I'm going to use, is this what you just had open?
Nope.
Back where you were. Thank you. OK, so the takeaways. Why did we just show you a library that you can't use? And that's all we talked about. The reason is because the library is simple. So this library is a made-up version of something similar to what we have at Eventbrite. The point is we want our data scientists to be able to do this, right? Anybody could go in and write a library that would enable somebody filling out these functions to be able to automatically ship it. So this is the important part, is being able to break out the 2 contexts, the streaming and then the data frame, and to be able to take either of those contexts and map them across extracting features, take the result, map it across predicting bulk. For some clarity, we do extract features using a map partitions function, right? So if you're on a data frame, do .2rdd, pass every single partition through your extract features bulk. Now you have a bunch of features in that partition. Do the exact same thing for predict bulk. But it could also work for UDFs. And doing UDFs is much faster because, again, we're in Apache Spark, right? So using I forget what they're called, but the vectorized pandas UDFs or something like that are way faster. The rest of our takeaways. Yep, so this consistent structure enables you to be able to automate prediction in streaming and in bulk. We may open source our actual predictor library, so this will be a little more interesting. And we'll try to figure out how to associate with this talk so you can find it. And the last thing is we're hiring. So if anybody's interested, we're going to be up here or over there. I don't know where we're going to end up. And if you have any questions for us, feel free to come by and ask us.
Yeah. So, thank you all.